Okay, all right, today, I'm gonna do 2 examples of what you're gonna have to do in your homework. It's gonna be pretty straightforward, but I wanna make sure that you understand what you're doing and how to do it, and then I'll let you go on your way to do your homework. Homework I send today will be due Friday. Now, if I didn't warn you, earlier this week, we will be having a test as possibly as early as Wednesday next week. That's as early as I want to push it, because I want to give you at least a week if you need to retake it. Make sense? Because the week after that, like the end of the week, Friday of like the week, not next week, but the week after, the end of the week is the end of the quarter. So I'm going to give you 1 week if you want to retake. Okay, yep, that's correct. So, all right, but here we go. First thing I want to make sure that you have written down, I want to have this. So I think we did one of these yesterday, but I just want to make sure that you have one again. Okay, let you write that down. This is my example today. We're going to eventually graph this, but I'll let you write this down. I'll give you the instructions of what we're going to do with it here in a second. I don't want you to write that. Perfect. Okay, this is one of my 2 problems I'm going to give you today. The question that they're going to ask you to do is to write this into different forms of a type of line. We talked about the types yesterday. We really focused on the bottom 3 yesterday. We did the special cases, general form, standard form. Those are the 3 that we did yesterday. Technically 4 because special cases has 2. But then on Friday, or Monday I should say, Monday, we did the top 2. So we did point slope and slope intercept. I'll probably use point slope first and I'll go to the other forms. So what I'm going to say is we're going to write this, we're going to graph this first. Every problem you have today you have to graph, so we're going to graph this. It'd be pretty easy because they give you coordinates, so that's kind of easy to graph. And then number 2, we're going to write this in standard form. Now, they'll say different forms they want you to write in. My strategy is always one and the same. I always go in the exact same format every single problem, so that's why I'm just going to say standard, because no matter what form they say, I always start here and I work my way down to get to the bottom one. So I start top and I work down. That's why I actually put them in that order on the board, because that's the order I actually write them in when I go through the work. Okay, so to graph this, what does an x-intercept and y-intercept mean?
So across the x, y axis.
Okay, yeah, so I'm crossing at -4 on the x-axis. There's my first point, let's call it point A. And then my second point is 7. I think that's 7. 1, 2, 3, 4, 5, 6, 7, yeah, and that's part B. So this is the actual line that I have. Okay, boom, there it is. So number 1, your graph, easy. If they give you coordinates, it's kind of stupidly simple, because you just graph the dots and you draw the line, done. Now, I have to come up with the equation for it. That's the tricky part. So what I actually need is I need the coordinates. So what is the coordinate for -4 for the x-intercept? What's like the actual coordinate written as? Yeah, -4, 0. Okay, so because you're only hitting the x-axis, so that 4 is the negative number, or is the x number. For the y-intercept, same exact idea, but the y is the 7. So 0 times 7. Make sure that you understand that. That's how the intercepts work. If it hits a y, then you're hitting the y as a 7. Okay. Now that I have that, you're going to need to go after slope. This is your average slope formula. We talked about this, I think, on Monday. That average slope is, the numbers you subtract to find the rise, and then you subtract the x to find the run. Or you can count with your fingers. Some people count. But what numbers do I have to subtract on the top from my coordinates? Which ones? Which ones are the y numbers?
0 and 7.
0 and 7, yeah. These numbers back here, these are the y's. So I'm using the back numbers. I don't care the order you put that in. Maybe you want to go 0 minus 7, top minus bottom, or 7 minus 0. I don't really care. But whatever way you subtract, you have to stick with that for the next one. So like this one, you have to stick with that same pattern. So I went top minus bottom, so I'm going to go top minus bottom on the bottom here. -4 minus 0. Makes sense? Like you have to stick with that same pattern. I always just put the 2 coordinates on top of each other, and that's the way I just work it. So now that I have slope, if I actually subtract, I get -7 over -4. So that's 7/4. Now the next part that I'm gonna do here is actually write my equation down in point slope form and then go from there. Okay, questions on how I graphed and how I found slope first? Okay, pretty easy. Let's go to point slope form here. This is my, I don't know why, but this is just one I always start with because I think it's kind of the easiest to start. So point slope form, I have my information, like my coordinates, and I'm going to plug in slope. So my slope that I'm going to use is this 7/4. I'm not even going to simplify it if you can leave it like that. And one of the coordinates, it's your guys' choice. Which coordinate would you like to use? Because you get to pick when you do point slope. Which one looks pretty to you?
X.
X. Okay. X is 0, is that what you said? Okay.
Yeah.
Okay, 0, 7. Okay, we're gonna pick that one. Okay. And again, you pick one of the two coordinates. You have to pick the ones that I provided you, just one of them. So I'm picking the 0, 7. So when I plug this into the slope form, here it is. It's y minus the 7, 7/4 x minus 0. I have to subtract these coordinates in there, and the 0 goes with the x, the 7 goes with the y, because it's alphabetical order. That's how I know where to plug these two numbers in. Right? And now I'm going to simplify this form, and it will get me to the other forms. It'll get me to slope-intercept, it'll get me to standard, and all that. But I want you to at least see this. Okay, are we good so far? Next step, let's distribute the 7/4 through. So I'm going to multiply this through the parentheses. This is where it could get dicey. Depending on your coordinate, if this is a really nasty number, and you're multiplying it by 7/4, my trick is, like, let's say this is a 5 in here. You take 5 times the top and divide by the bottom. Don't write it as a decimal, leave it as a fraction. So it'll be, if that's a 5, that'll be 35/4. That's how I leave it, because the 5 times the top. Does that make sense? Like, leave it a fraction. Because the next step will get rid of it. So if I distribute, I don't have to worry about that, because 7/4 times 0 is 0. So I have 7/4 x minus 0. Okay, next step, I'll add the 7 across to get to slope-intercept form. So if I add the 7 across, this is what I have. Negative 0 plus 7 is 7. So there's your slope-intercept form. I told you, like, it's very easy, like, if you're going from one form to the other, just to rearrange really quickly. That could be a problem, because if it's 35/4, like I said earlier, and you're adding a 7 to it, you're going to get common denominators and do all the correct math. Or just make it decimals. Some people do that, but I prefer not to. Now the last step is to get to standard, because that's what the whole question was. Standard, I need to move this x to the other side, so it's negative 7/4 x plus 1y equals 7. And I notice I introduced the 1 from the y. I like to have numbers there. You don't need to, but I like to. And now to get to standard form, you can't have a fraction or decimals. So if there's a bunch of decimals on this problem, multiply by 10 or 100 to get rid of the decimals, everything. On my case, I have a fraction, agreed? You always multiply by whatever's on the bottom. So what number am I going to multiply by? 4, right? You're going to multiply everything by 4. If I multiply everything by 4, here's what I get. Negative 7x, because the 4 would cancel in the front. I'll get a 4y, and I'll get a 28 in the back, because I multiplied everything by 4. That's standard form. Questions at all about the process for how to go from point slope to standard? Now sometimes they don't ask you for that. They don't ask you for standard. Sometimes they just ask for point slope form. Fine, there's two options. Sometimes they want slope intercept, fine, you have it real quick. Sometimes they want you to go to standard or general. General, I just have to move the 28 over with the 4y, right? Because generally you have to have 0 on the one side. Now, if you check the back of the book, they might have different answers because they might have picked a different coordinate than you. So the final answer might look different, but it's probably just a multiple of this one. Maybe it's everything multiplied by 2 by accident. So it would be a negative 14x plus 8y and a 56. Because that would be a scalar multiple. It's still the same answer. So don't feel like you're doing it wrong. Because they might have picked the negative 40 instead and got a different look than yours. Okay. Questions at all about the process here? Okay, let's do one more. Then we're done. And then I'll let you kind of work on your assignment today. And I need to give you graph paper. All right, so the next one, instead of giving you coordinates, I'm going to give you an actual equation and we have to go graph it. I think there's one or two of these where they ask you to graph. And I did some of these yesterday where I gave you systems, or not systems, piecewise functions. So that will be one of the first problems you're going to have. I'm just going to give you kind of an easy one right now. So negative 3x plus 2 for any x that's less than negative 1. I'm going to have 5 for any x that is less than or equal to 2 but greater than 1. And half x for any x that is greater than or equal to 3. Okay, we're going to graph this. This is a piecewise function. There should be 3 pictures in one graph, and they're telling you what numbers you need to plug in. I'm going to warn you right now, one of your problems you're going to have, there will be a curve. One of the problems will be a curve, so you're going to have to like plot a couple points to see where that thing's going. Remember, you have a starting and stopping point. This one will have an arrow, because it starts you at a number, but it keeps going forever in one direction. This one starts you at a number and keeps going in a direction. And then this one in the middle has a starting and stopping point, so it's almost like a segment. Stick. Okay, are we ready to go? We understand what we're doing here? We're graphing these. These are like the first 3 that you have, I think. Let me get rid of that graph, sorry. And I'll try to color code as we go. I'll try to do top, middle, bottom, so I'll put these in different colors. So I'll do the top one in red, we'll do the middle one in blue, and then the bottom one in black. So you can kind of see where they go. Okay, so let's do the top one. On the top equation, what's the first number I should plug in?
Negative 1.
Negative 1. It'll be an open circle though. I'm really not supposed to use negative 1. I'm supposed to use every number less than negative 1. But I always plug that number in first for an open circle, and then I can draw the line from there. But I'm going to plug negative 1 in first. So this is the part you can kind of do in your head. What I mean by plugging negative 1, that's the first number I'm plugging. I'm plugging negative 1 into the x's in here, and then whatever the y answer is, that's the dot I'm going to go draw. So negative 1 times negative 3 is what? Positive 3. And then you add 2, and that gives you 5. So negative 1, comma 5, I'm going to have an open circle there. And make sure that's blatantly like open. Like I'm drawing it bigger than probably normal. So open circle. And now I need to plug in numbers that are less than negative 1. I know this is linear because there's no powers on that thing, so I know that I can just draw one more dot and I'm good. So what's a number that's less than negative 1? Negative 2 or negative 3, it doesn't matter what you're going to pick. I'm going to pick negative 2, that is a number clearly to the left of negative 1. So negative 2. Negative 2 times negative 3 is 6, and I add 2, I get what? 8. And that's a closed dot, because that number does work. So negative 2, 8. And so here's where this thing is going. It's going that way. Oh, did I just go in the wrong color? What am I doing? Drawer. Red. Whatever, we'll switch that. Alright. Okay, we're good with the first one. Do we understand how I did it? Do we feel comfortable with that? Second one. Second one's kind of easy. It's just a horizontal line. Y is 5. But here's the numbers I have to hit. I have to start at 1. I have to go up to 2. There'll be an open circle and a closed circle, and the answer is always 5. So if I plug in 1, the answer will be 5, right? Because you can't plug in 1 anywhere, so the answer is just 5. If I plugged in 2, the answer is 5. And these are the 2 numbers I have. This will be a closed dot, that'll be an open dot. So at 1, I'll have 1 comma 5, open dot, and then 2 comma 5, closed dot, and there is a line between. Do you see how that works? That's a horizontal line because it's just a number. And then the last one is I'm starting at 3 on this next one. I'm really going off in these color situations here. What am I doing? All right. The next one I'm going to plug in 3. And is this going to be open or closed dot? Closed. It says that little bar. So it's going to be closed dot. When I plug in 3, 3 times half is what? 1.5? 1.5? You're basically dividing by 2. Let's plug in a number that's greater than 3. Let's go 4. Okay, 4 times half, that's 2. And now I can draw those. And this could be a closed dot to begin with, and then the arrow will be going that one direction. So 3 comma 1.5, 3 comma 1.5, 4 comma 2, And here's where that thing's going. So it is a piecewise function. There's breaks in this graph, so that's why it's piecewise. All right, questions, comments about the actual like domain, how to graph, how to do linear functions. Again, one of the problems will have a curve. Okay, homework's on the board. You can see it over there. It's page 175, 188. I'll put that up here on the board in case you don't want to turn around all the way. Unique graph paper. You have to graph every single problem. There's only 12 problems. I counted them up. You'll need one graph paper because there's 12 graphs on that. If you mess up, you won't have enough graphs. So what I'm asking you to make sure of right now is do not use pen. Use pencil. Use pencil if you make mistakes. So you have to go fix it. Okay, here's a graph paper. Make sure you put your name on it. Every single problem will be graphed. So I don't know if you'll necessarily need extra like notebook paper, but it wouldn't be a bad thing to have, I guess. There you go. I'm gonna put this on the main board here so you can see it. So page 175, numbers 46, 47, 54. You're going to graph all those, and then page 188, numbers 14, 15, 22, 29, 30, 46, 38.
That's what you should go for.
60, 64. Alright. There should be 12 problems total. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yes, 12, and you're going to graph each one. Some of them are easier than others. First 3 are probably the ones that will take the longest. Well, there you go. The rest of the time is yours.